Hello guys, welcome to our course on Python for data analysis, and in this section we'll be talking about data visualization. We'll explore Matplotlib and Seaborn, which are some of the most widely used plotting libraries in Python, and they allow us to create high quality visualization for data analysis and presentation. But before we get started, you know what to do. Don't forget to like the video, subscribe to the channel, and put your question in the comment section.
9 to 5 data.
Data visualization involves representing data graphically to gain insight, identify patterns, and communicate findings effectively. Visualizations help us to understand complex data sets, explore relationship between variables, and present results to stakeholders in a clear and compelling manner. Matplotlib and Seaborn provide a wide range of functions and methods for creating various types of plots, which include line plot, bar plot, histogram, scatter plot, and many more. So this makes this library a powerful tool for data visualization in Python. So we will explore some of these charts or plots that are used mostly in data visualization. We'll be doing that with Matplotlib and Seaborn. By mastering these libraries, we can create publications quality plots, customize visualizations to meet specific requirements, and enhance our data analysis workflow. So let's understand what each of these plots are used for, or what they are best used for. So we have line plot, which is used to identify trends over time, and we can use it to identify trend of multiple categories, as we have seen. For example, this is used to identify the time trend of these categories. Also, we have bar charts, which is used for comparing quantities of different categories. We can use it to compare counts or maybe other statistical values like mean, and trying to understand the median or the mode. We have pie charts, which is best used for representing part of a whole, like dividing or seeing how a particular whole is divided into segments, just like the segment of a circle or sector. We also have histogram, which is used to visualize the distribution of a data set, and also the shape of the histogram also speaks a lot about our data. So for example, we have normally distributed data, we have data that are skewed, or from the shape of the histogram we can also determine if our data has outlier. Also, we have scatter plots, which is used to visualize relationship between two variables, and it also helps us to identify correlations, clusters, and also outliers. We have box plot, which is used to visualize the distribution of data, and this is a very important plot because they show the median, the quartile, and potential outliers we might have in our data. So we'll move to our Jupyter notebook now to show how we can use Matplotlib and Seaborn to plot all of these charts that we have discussed here. So for each of this chart, we'll be having an hypothetical data generated, so for us to be able to understand how the plot is used. So before we start, we need to import the needed libraries. So importing the needed libraries. So we'll be needing Matplotlib. Import matplotlib.pyplot as plt. So we need Seaborn. Import Seaborn as SNS. Import pandas as pd. Import numpy as np. So for our data generation, we need the pandas and NumPy, and for the visualization we need the Matplotlib and Seaborn. So most of all the transformation or data manipulation will also be done using pandas. So we'll be starting with the line plot. So for line plot, let's do some data generation. Data generation. So we want to get a random data, random number. So dot seed and also month. So the data we want to generate is the sales of two products. So we are going to do a time trend analysis of the product. So we need to generate months. So we need to generate 12 months. So we do np.arrange. So we want 1 to 12. And then the product A. Sales. So now we want to generate some random integers for the sales for each of the months. So we do np.random.randint because we want to do random integer, and we want to start from 100 to 200, and the size should be 12 since we are dealing with 12 months. So let's generate for product B also. Product B sales, same code dot random dot rand int, and this time around let's do 150 and say 250 and do the same size of 12. So after we have this, then we use pandas to transform the data. Transform data using pandas. So we'd say sales data equals pd dot data frame, and we'll supply the data in terms of dictionary, because we want the column to be months, which is the 12 months, and we want the product A to have the value of the product A sales and product B to have the value of the product B sales. So we'll do something like that's dictionary key month, and the value will be the month we generated at the top. So we want to get product A, then the value will also be product A sales, so we want to get product B, and the value will be product B sales. So we are done with the data generation. So let's run this. Hopefully, okay, there's an error somewhere, so we need to take care of the error. So the spelling of arrange should be arrange single R. So this should be small letter P. So sometimes that is why you should try and avoid writing long codes, because sometimes if you write too long codes, it will be difficult to catch where the error is coming from. And if you write your code in short blocks, it will be easy for you to quickly target where the error is coming from. So That is the data generation. So let's make the visualization. So using Matplotlib, plotting with Matplotlib. So since we already convert everything to data frame, so the next thing is to plot. And to do that, we want to plot the data. So to plot the data, what we need to do is to understand the output we want to get. And the output we want to get is to have the month as the x-axis and the sales as the y-axis, and also use a label like some kind of a legend. So let's do that now. So we'll do plt.plot. Plot is the first method we'll use, and the plot takes in some key values. So we have the sales, which we are to, the first value is the x-axis, which is the month. So sales data, and we want to access the month. So after that, we need our y-axis, which is the product, sales data, and product A. So we also want to be able to use this product as a label, or let's call it as a legend. So label equals product A. And then what color do we want to give to this? We'll give it the color of blue. So let me skip this part first so you understand why we are doing this label. So now that is the first product. This will give us the line, the first product. This will draw a trend for this. So let's do the second product. So we'll do the same formula, and we just change this to product B. And after that, what we need to do now is that we need to also specify what will be our X label. X label will be month, and our Y label, the title of the Y axis, plt dot Y label, will be product, let's say sales. And then what is the title of our chart that we are drawing? Plt dot title will be monthly sales comparison of products A and B. And then what we're going to do now is, do we want the grid line? So sometimes, let me just say, no, we don't want the grid line. But since we are doing a line chart, so let's bring the grid line. So plt.grid, and it takes in a boolean value, so we'll say true. And then the next thing is that we now want to show our line chart. So plt dot show so we have our line chart, and once what we can see from here is that we actually have two products which we are seeing the monthly trend, this monthly sales trend of the two products. But right now, what we don't know is that which one is product A, which one is product B. So we can do this by introducing label into our plot, and then we use the label as the legend for the plot. So let's go back to product A, the line of product A, then we'll do label equals product A. And then we can change the color if we like. So I'll just leave the color the way it is. I won't change that. So we'll do the same thing, label equals product B and then we need to add something to this. Now we need to on our legend so that it will display on the chart which one is product A, which one is product B. So let's do PLT legend, and it doesn't take any argument. So let's rerun this. So we can see the result now, that now we can understand which one is product A and which one is product B. We can see the blue color is product A and the orange color is product B. So that is how to use Matplotlib for line visualization. So let's try to use Seaborn now and see what's the difference between the two. To use Seaborn, there's actually a bit difference in the way the data is being transformed, because for Seaborn we need to do something called data melting. So, and it's some kind of data transformation to actually allow us to be able to plot with Seaborn. So first we need to melt the data, and from there we'll say sales data melted. Let's do sales data. To take in sales data dot met, which is the method we are going to use, and the values it takes in is that we have something we call ID variables, which is something like the x-axis we have at the top. So we'll say ID vars, then we'll give it the x-axis, which is the month. Then it has something else again, the variable name, which we can say are the product. Like, since we are doing comparing two products, so it's something like a kind of legend in Seaborn, so it doesn't have the label the legend method like the way we've used it in Matplotlib. So that's why we are doing this separately. So we'll say var name, variable name. So we'll do product, so we name it product, and then the value name. So these are the ones that will go to the y-axis, and we'll do sales. So right now there's something I did not tell us above about the plotting. So the first thing you need to understand is that if you want to plot, you need to understand your plot area. So the plot area is what will determine the size of your plot, the width and height. Do you understand now? So it's important you have it, but because we are comparing two variables at the top for Matplotlib, it's kind of difficult to do that because it will split the two variables into two, and we want them to be on a single plot. But for Seaborn, we can actually apply that format here. So let's say plot area. To do that, we do plt.figure size .figure, and then we'll give it the figure size, fixed size, equals supply the width and height in, we want to 10 pixels by 6, and then we use Seaborn. Using Seaborn, we do SNS dot line plot. So we use the line plot directly. And for the line plot, we need to supply our data. The first thing we need to supply is data, which is the melted sales data. We say sales data melted, and then it will ask for our x-axis, which is the month, and what's our y-axis, which is the sales. And after that, we need to give it color to separate the two products, and we say EU equals to product, And with that, we also need to add the label and the title. So we do plt.x-axis x label, and that's month. So plt.y label, that is sales. Plt dot the title, give it the same title, we'll say monthly sales comparison of products A and B. So also we want to show the grid line, so we'll do plt dot grid, and you say true, and then do show plt dot show. So we can see we have the same thing as we have above for the Matplotlib. So the only difference is just the plot size. So that is how to do line plot using the Matplotlib and the Seaborn. So the next thing we want to get into is the bar chart. And to do the bar chart now, we also need to do data generation. So let's just generate another set of data generation. And we'll say cities. So what we want to do is that we want to compare the population of, let's say, 5 different cities. So, and this should be easy using bar plots. So we'll start by having different city names. We'll say city. So city A, we can say, let's say this is London, this is Barcelona, this is New York, then let's say we have Moscow, and let's say we have Lagos. So these are the list of cities. Then we can have the population of the city. Let's say populations of the city. Then we have another list. We say we want to say 900,000 for London. Let's say 600,000 for Barcelona. New York 1.2 million. Let's say Moscow 1 million. So, and Lagos, let's say Lagos is 2 million. So for this now, let's run this. This is the data we've generated for the bar chart. And from here, we can now plot using Matplotlib. Plot using Matplotlib. So we'll do, like I said, the first thing we need to do is our plot area or plot size. Plot area or size. Then we'll do plt.figure. Then we'll say fig size equals, we'll provide, let's say 10 by 6. And after that, all we want to do is then we use the bar method with the Matplotlib. We say plt.bar because we are trying to do bar chart, and then it takes in the x and y. So the x is the city and the y is the population. So we just give it the cities and population. So after that, we do our title and the label, plt.x label. We'll say cities, and the next thing, plt.y label. We'll say populations, and then what is the title of our chart? We'll say plt.title, and we do population comparison of 5 cities. So let's show our chart. So here we have our chart. We can see at a glance the population of each city, and it's easy to identify which city has the largest population and also what's the actual population of each city. So to use Seaborn, we can also use Seaborn to do this. And to use Seaborn, let's say using Seaborn. So what we need to do first is we need to format the data and change it to pandas data frame. So we do data equals pd.data frame, and would say we'll do dictionary method and say city, and the value will be the city we created earlier, cities, and also we'll say population, and that will be the population we created earlier. Population, just want to be sure. Okay, I added s populations, and after we run that, then after we have that, then we can start using our Seaborn. So the first thing, plot size, which is plt.figure, and fig size, which equals 10,6. And from there we bring in our Seaborn, which do sns.barplot. So that's the method for Seaborn. In PyPlot, which is in Matplotlib, we use the bar method, but in Seaborn we are using barplot. So and what it takes in is, first it takes in the data, which equals to data we created at the top, and then it will take in the x value, x, which is a city, and what should be our y, equals to population, and from here we can add our title and label, plt.x label, and we have cities. After that, plt.y label, we have population, and let's say the title, plt.title, we have population comparison of 5 cities, comparison of 5 cities, and then let's render our visualization. We'll do plt.show. So we have the same thing and we have the same look, so it's just that, you know, it depends on your preference. So that's using Seaborn, and you know, for us to use Seaborn, we need to do additional data transformation. Actually, in the real world analysis, most of the data we'll be working with would already be in pandas data frame format, so it will be easy to use Seaborn without needing any further transformation. So let's go to pie chart. For pie chart, the first thing we need to do, like usual, is to do the data generation. And the kind of analysis we want to do with pie chart is that we want to see what is the market share of 5 companies. So let's say we have 5 companies, what is their market share? And by doing this, we can use pie chart to make the visualization. So let's create something like dictionary to generate our data. Let's say market share, or market shares, and we'll do company A, let's say Facebook. And what's the market share of Facebook? So let's try and understand. This is just an arbitrary values I'm putting. I'm not saying the actual value here. So let's just say maybe something like 25. So another one, let's say the next one, Amazon, and the value, let's say something like 20. Another one, let's say Apple. So let's say something like 15. And another one, let's say Netflix. Let's say something like Netflix, let's say something like 30. And let's say the last one here, we'll say Google. And let's say something like 10. And now we can save from this. Now we can save the company, we can get the keys and save it into the companies, and then we can get the shares and save it. We can get the values and save it into shares. So let's do that. So let's say companies names, companies. So we want to save that into a list and say market share dot keys, because it's dictionary, so we want to get all the keys. Dot keys, so it has this at the back, so don't forget that. And we want to get all the shares they have. We'll say shares equals list and market shares again, market shares, and we want to get the values dot values. So we have our data. So the next thing we want to do now is to plot using Matplotlib. Plot with Matplotlib. So to do that, we first set our plot area, plt.figure, and fig size 10,6. And after that, what we need to do is that we need to use the pie method to then create the pie chart. So we'll do plt.pie. And this one now, the first thing it takes in is the values we want. So the values we have here is shares. And after that, it takes in the company names, like it takes in the label, which will then supply the company name. So the labels, which should be companies And we then need to do some formatting on this now. Like for example, we need to format the percentage, the way the percentage will display, and also alter the displaying angle of each of the pie. So this, you can Google search more about this. So this is part of the argument in pie chart. So just to format the percentage, auto PCT equals, then we'll do this percentage 1.1 F and then percentage again and again. So the other thing is the starting angle. We can say start angle 140 degree, though this is not important, but the only reason why we need it is to ensure that we have the pie chart rotated in a readable format or readable manner. So then we'll give it our title, plt dot title, and we'll say market share of top 5 companies and let's render our charts, plt dot show. So the main reason why, if you look at this now, you see we did not specify X label and something like that, because it's different from the kind of from the type of chart we've been doing from above. So this is pie chart, and the label, we already specified the label in the pie, in the pie method, and the value it will get. So we give the value first, then the label. So all this will be used in the building of the visualization. So let's run this. Oh, so sorry. So this should be company, and then we have this. So we have market share of, it's not if, of top 5 companies. So you can see the way it's displaying: Facebook 25%, Google 10%, Netflix 30%, Amazon 20%, Apple 15%. So the way it has composed this is that what the values we specify has already been used as the percentage, because it sums up everything, and then what is the percentage of Netflix in the whole submission. So whatever the whole submission is, Netflix percentage is 30% and Apple is 15%. So that's what we have in the visualization here. So we can also do this in Seaborn, but there's no actual difference, and in my own experience, Matplotlib does this better than Seaborn, so I'll just leave it as this so we don't go to Seaborn. So the next thing is that we'll go to histogram, and for histogram we also need to generate data, and this time around we just generate a random number for a normal distribution. So for people that are really grounded in statistics, they know what a normal distribution is. So this is not a statistics class, so I won't be discussing about normal distribution. So we just show us the visualization of it, which is done mostly using histogram. So let's generate the data. So generate data. So we want to generate 10 random, want to generate 1000 random number. So data equals np dot random round number, round n, and then we'll specify how much. We'll do 1000 and we'll run this. So after that, let's visualize using Matplotlib. So using Matplotlib, so we do the plot area first, which is plt.figure, and fig size equals the same size we've been using, 10,6. And after that, what we're going to do is use the plt.east. The east method is the method to visualize histogram in Matplotlib. So we use east, and then it asks us for the data, we supply the data, and the next thing to ask us is that it will ask us for bin. So that is the way histogram is being visualized or being constructed. We have to group our data into bin for us to be able to create a visualization of histogram. So after we have the data, we need the bin. So I'll just supply, let's say 30, and then sometimes it's not advisable, but sometimes it is useful to say the edge of the visualization. We can say let's be black, edge color equals black, and the next thing again, we can add the title and the label plt dot title. So it is histogram of 1000 random numbers from a normal distribution. So the next thing is, let's say the x label plt dot x label, and that is value, and plt dot y label will be the frequency, how frequent each value is occurring. Plt dot y label, say frequency, and let's render the visualization. Plt dot show, and there's something wrong here, so this it should be a string. So let's run the stuff again. So what's wrong again? So we have our histogram, and it said it got an unexpected keyword argument of bin. So I'm so sorry, this meant to be bins. So let's run again. So yeah, we have some result now, and we can see. So sometimes it's good to have this error, so you'll be able to understand what you are doing wrong, and you, from the error, you should know what you need to change in your code to get the result. And sometimes if you can't debug it yourself, then you can copy the error to Google or to any AI chat of your choice, then you get a result. So let's move to scatter plot. So for scatter plots, we also need to generate data. So we just say x equals to np dot random number random dot rand, and let's say we want 50 random numbers. So our y value, we also say np dot random dot rand 50. So let's run this, and then let's do the visualization. So the first thing, like I said, is our plot area using Matplotlib. So plt dot figure fig size, and we have the 10,6. And after that, we need to use the plt.scatter method to be able to plot our scatter graph or scatter plot. Plt.scatter, and this one now, since we know scatter plot is just to get what is the relationship between two numerical variables, so we just passing the two numerical variables, we passing the x and the y, x comma y, and after that our usual label and title, plt dot title scatter plot of 50, it's 50 random points, yeah, random points and from there we'll say plt dot x label. What should be our x label? We just say x-axis and the y label, plt dot y label. You just say y axis, and then we show our graph, plt dot show. So this is 50 random points, so it's just random numbers or random values, so there won't be any relationship or any correlation or any sort of relationship between these variables because we have done just 50 random points. So in the real world, if you do scatter plot, it's usually to get what's the relationship between two variables. So that's that about scatter plot. So let's move to box plot. So box plot is the last one we'll be discussing here, and let's do the data generation for it. Data generation, and we say data 1, because what we want to do is that we have 3 products, and we are assuming that we have 3 products, and then we want to see what the distribution of this product are, what's the sales distribution of this product. So let's say data 1, which will be for, let's say product 1, we'll say mp dot random dot normal, say 100, 20 and 200. So we do the same thing for data 2 and 3. So data 2, so we just change the value to, let's say 80 and 30, and then data 3, just change the value also to, let's say 90 and 25 for this. So then we can all put this together into a single data. So say data equals to the list of all the above, data 1, data 2, data 3. So let's run this, and then we use Matplotlib to get the visualization using Matplotlib. So we'll say the first thing, plot area, plt.figure fig size, and 10,6, and then our plotting, which is plt dot, we say box plot, we use the box plot method, box plot, and the box plot takes in the first value is the data we want to use, and after that, what are the labels that should be given to each of the box labels, and we supply that in list. Say product 1, product 2, product 3, and after that we'll do our usual chart formatting, the title, the label, plt dot title, and we want to say sales distribution of product, so the x-axis will be the x label, will be the product, plt x label, and that will be products, and the y-axis will be the sales figures, plt y label, This is sales figures, and then we'll render visualization plt.show. So this is our visualization now. So from this now we can see what is the middle sales of product 1 and what is the middle sales of product 2, and same for product 3, and we can see if each of the product have outliers, or what is the minimum and the maximum. And from here we can also get what is the interquartile range and all of these statistical values that we might use to perform advanced analysis. So now we have come to the end of data visualization in Python, and in the next video we will take on a hands-on example of how to put all this together and build a real-world data analysis using Python. So don't forget to like this video, put your question in the comment section, and subscribe to the channel. Happy coding.